Welcome to The Explainer. I am so glad you're joining us today because we are going to unpack the literal, invisible magic that runs basically our entire modern lives. We're going on a little journey, starting all the way down at the microscopic world of atomic physics and zooming out to this massive global infrastructure shift it's literally rewiring our planet. If you love figuring out how the world actually works behind the scenes, you are absolutely in the right place.
So, think about something we all do, like every single day. You walk into a room, you flip a switch, and boom, the lights come on. But I want you to look past that plastic switch on your wall for a second. Where is that power actually coming from? Right, most of us know it comes from a power plant, sure, but the sheer complexity of the systems powering our daily lives and the mind-blowing engineering making it all happen is actually going through a massive transformation right now. Okay, let's dive into this. Section 1, the magic of induction.
To really get this, we have to rewind to 1831. A scientist named Michael Faraday realized something so profound it essentially changed human history overnight. He figured out that generating power, at its absolute core, is basically just spinning a magnet inside a wire coil. He found that if you take a magnet, which power stations usually call the rotor, and you move it inside a stationary coil of copper wire, called the stator, something genuinely magical happens.
And that single foundational principle, electromagnetic induction, is the beating heart of nearly all global power generation today. By moving that magnet, you physically push electrons through the wire. And that flow of electrons? That's the electrical current charging the very device you're watching this on right now. Honestly, it doesn't even matter if it's a dirty coal plant or a high-tech nuclear reactor. The ultimate goal of all that massive infrastructure is simply finding a way to keep that one magnet spinning.
Moving right along to Section 2, the turbine era.
So, to get that massive magnet spinning at an industrial scale, we rely on something called the Rankine cycle. It's this crazy closed-loop system of immense pressure. First, a boiler burns fuel, could be coal, natural gas, or even nuclear fission, to heat water into really high-pressure steam. Next, that steam is blasted onto the blades of a turbine, which makes it spin at just incredibly high speeds. Then, that spinning turbine turns a shaft connected to our giant magnet inside the generator, basically converting physical motion into electricity. And finally, a condenser cools the leftover steam back into water, and the whole cycle just loops all over again.
Now this turbine-based thermal process, it is an absolute workhorse. Looking at the US grid, natural gas currently leads the pack at 43%, followed by nuclear at 18% and coal at 16%. But check out that bright green slice catching up at 20%. Those are renewables, and they're growing so fast. And as we're about to see, some of these renewables are pretty much rewriting the rules of physics as we know them.
Which brings us to Section 3, direct energy conversion.
Because all this raises a super fascinating question. What if we could just break the rules? Like, what if we could generate power without boiling water, without steam, and without spinning a magnet at all? On one side, you've got traditional turbine generation. An incredible feat of engineering, for sure. But it involves tons of moving parts, extreme heat, massive friction, and it is incredibly loud. On the other side, we have direct conversion. Think about how wild this is. We are generating immense power without boiling a single drop of water, in complete, motionless silence. Tech like solar panels or fuel cells don't use kinetic energy. They actually use photovoltaic or chemical energy to create electricity directly.
Let's actually look at how solar photovoltaic or PV generation pulls this off. So, solar panels are made of these semiconductor cells, mostly silicon. When photons from sunlight hit these cells, their energy gets transferred to local electrons in the material. These electrons are literally knocked loose and just start to flow. That flow creates direct current, or DC electricity, which runs through an inverter to become the alternating current that your home uses. No moving parts, near-silent operation, and it makes power generation completely accessible right at the household level. It's a total game changer.
All right, let's zoom out a bit. Section 4, the centralized power paradigm. For the past century or so, we've basically relied on what's known as the hub-and-spoke model. Think of it like a giant water tower feeding a whole town down a very strict one-way street. Traditional thermal plants needed massive economies of scale to be efficient, and honestly, they produced a lot of pollution that we obviously wanted to keep out of our city centers. So we built these massive power plants way out in the middle of nowhere. The electricity then flows down that one-way street through those huge high-voltage transmission lines, down into local distribution networks, and finally, out to you, the consumer.
But, as you might guess, this centralized model has some pretty severe physical and economic limits.
Just transporting this power over those huge distances eats up over 7% of it, just lost to wire resistance alone. I mean, that is a staggering amount of wasted energy. On top of that, building and maintaining all this massive infrastructure costs an absolute fortune. It relies heavily on fossil fuels, which means high emissions, and because the whole thing is connected in this giant top-down web, a failure at just one major plant or transmission line can trigger those cascading network failures and cause massive sprawling blackouts.
So how do we fix this? Section 5, the distributed generation shift.
This is the massive paradigm shift completely transforming the energy sector today. Distributed generation is exactly what it sounds like. Electricity produced at or near the exact point where it's going to be used, completely bypassing that huge transmission network we just talked about. Thanks to deregulation in electricity markets and just huge leaps in tech like rooftop solar, micro wind turbines, and local fuel cells, power generation is packing its bags, leaving the distant countryside, and moving right into our local neighborhoods.
If you look at this comparison, the contrast is honestly pretty stark. Centralized generation, it's massive, it's far away, and it suffers huge transmission losses, pushing power down a one-way street. Distributed generation is the exact opposite. It's small, local, right at the point of use, with negligible loss and a super flexible two-way flow. This means a house with solar panels can consume energy when it needs it, and then instantly feed any leftover energy back into the local network for others to use.
And check out this staggering metric that really shows just how efficient going local can be. 90%. Traditional centralized thermal plants only convert about 40% of their fuel into actual electricity. The rest? It's just lost entirely as waste heat venting out into the atmosphere. But when you use a distributed generation setup called combined heat and power, or CHP, you can capture that waste heat on-site and use it to heat local buildings or water systems. Because the plant is literally right next to the consumer, overall efficiency skyrockets to an unbelievable 90%.
And as you can see here, by doubling fuel efficiency and cutting out that transmission loss completely, distributed cogeneration drastically lowers our carbon footprint when you compare it to standard centralized coal or gas plants. It turns out to be an incredibly powerful tool for reducing global emissions simply by using our energy a lot smarter and, well, keeping it closer to home.
The absolutely crucial takeaway from all this is that the grid of the future is no longer this passive one-way street. It's becoming a highly active two-way ecosystem. Driven by environmental needs, market changes, and just incredible tech leaps, everyday consumers, yeah, maybe even you with some panels on your roof, are becoming active energy producers. Homes and businesses are starting to act as their own mini microgrids, generating, storing, and sharing their own electricity. Which leaves us with this final, kind of provocative question to think about. Are we witnessing a true change of paradigm as distributed tech like solar, microwind, and advanced local networks get more efficient and much more accessible? You really have to wonder if the century-old era of the massive, centralized power plant is finally coming to a close. It is such a thrilling shift from Faraday's very first spinning magnet to a world of millions of decentralized microgrids powering our future. Thank you so much for joining me on this explainer, and definitely keep questioning how your world works.